User notes for section 7.6. Okay, so here we are, 7.6, 1 to 33 odd, page 413. There's some of the problems. 33, so there we go. Answering the back of the book. Okay, now, word of caution, the book has parentheses and brackets. I'm going to be using open and closed circles. So for this and this, I'm going to use closed circles instead. For this and this, I'll use open circles. So it's going to be a little bit different in the book. What the book has is not wrong. It's just a different way of expressing the answer. Okay, so there's that. And all right, so this time we're trying to solve quadratic inequalities. Okay, so number one, x squared plus x minus 6 is greater than 0. Factor x minus 2, x plus 3 is greater than 0. Okay. Pretend temporarily it says equal and get your zeros. That would be 2 and negative 3. Those are your boundary numbers. Okay, so I put a circle on negative 3, circle on 2. Now, if I were to have a line underneath here, I would have closed circles. These are open circles. So negative 3 and 2 do not satisfy the inequality. If I were to plug in negative 3 plus 3 is 0. 0 times that is 0. It would say 0 is greater than 0. That's not true. If I plug in 2 here and here, 2 minus 2 is 0. 0 times that is 0. It would again say 0 is greater than 0. False, so open circle. If you had the line underneath it, though, greater than or equal to, they'd be closed. Again, in the text, they use parentheses. Okay, ignore the shaded region for now. There's no shading yet. Then you pick a number in regions 1, 2, and 3 and test it against the original inequality. So a number here is like negative 4. Number here is 0. Number here is 3. Plug in negative 4. I only need the sign. Negative 4 minus 2, negative. Negative 4 plus 3, negative. Negative times a negative, positive. Is the positive number greater than 0? Yes, that's true. True means I shade that region. False means I don't shade that region. Try 0. 0 minus 2, negative. 0 plus 3, positive. Negative times a positive is negative. Is a negative number greater than 0? No, that's false, so I don't shade in region 2. Region 3, the number 3. 3 minus 2 is positive. 3 plus 3 is positive. Positive times positive is positive. Is a positive greater than 0? Yes, that's true. So I shade that region. So that's the basic idea behind all these problems. Okay, 6x squared is less than 5x minus 1. You want everything on one side and 0 on the other. So I subtract 5x and add 1. Looks like this. Okay, factor 2x minus 1, 3x minus 1 less than 0. A little bit of algebra. The boundary numbers are whatever makes this 0, whatever makes this 0. That would be 1/2 and 1/3. Not a very large interval. So here's 1/3, here's 1/2. Pick something here, 0. Now, how do I get something between 1/3 and 1/2? Well, I would think in decimals. This is 0.333, this is 0.5, so I pick 0.4. And then over here is 1. Okay, plug in 0. Put a 0 there, this is negative. Put a 0 there, negative. Negative times a negative is positive. Is a positive less than 0? No, that's false. And by the way, notice again, it's strictly less than, so these are open circles. Again, in a book, they would have parentheses. 0.4. 2 times 0.4 is 0.8 minus 1, that's a negative. 3 times 0.4 is 1.2 minus 1 is a positive. So a negative times a positive is a negative. A negative less than 0, that's true. So I shade in region 2. Region 3, 1. 2 times 1 minus 1, that's positive. 3 times 1 minus 1, that's positive. Positive times positive is positive. Is a positive number less than 0? No, that's false. So the only shaded region is just this small region here between 1/3 and 1/2. 21, x plus 1, x plus 2, x plus 3 less than or equal to 0. Now there's a line underneath it, So they're going to be closed circles at whatever makes that 0, that 0, that 0. That's -1, -2, -3. So closed circles at -1, -2, and -3. Logic, okay, let me just say -2. If I put -2 here, here, and here, well, -2 plus 2 is 0. So 0 times whatever these is 0. It would say 0 is less than or equal to 0. That's true. Same logic applies for -1 and -3. So these are closed circles. In the text, in the back of the book, they use brackets for these. Okay, this time I have 1, 2, 3, 4 regions. Okay, region 1, I picked -4. Region 2, -2.5. Region 3, -1.5. Region 4, 0. Okay, -4 plus 1, negative. -4 plus 2, negative. -4 plus 3, negative. 3 negatives makes a negative. Is a negative less than or equal to 0? That's true. Shade in region 1. -2.5 plus 1, negative. -2.5 plus 2 is negative. -2.5 plus 3 is positive. So 2 negatives makes a positive. Is a positive less than or equal to 0? No, that's false. Don't shade in that region. Region 3, -1.5. -1.5 plus 1, negative. -1.5 plus 2, positive. -1.5 plus 3, positive. So negative times positive, negative. Negative less than or equal to 0, that's true. Shade it in. And 0. 0 plus 1, 0 plus 2, 0 plus 3, they're all positive. So the product is positive. Positive less than or equal to 0, no, false, don't shade in that region. Okay, if you have a fraction and quotient, you pretty much do the same thing. You'll set both the top and the bottom equal to 0. Okay, so what makes the top 0? 1. What makes the bottom 0? -4. Okay, test each of those boundary numbers. If I plug in 1, I get a true statement. 1 minus 1 is 0, divided by that is 0. 0 is less than or equal to 0, that's true. This time -4 is not shaded, because if I try to plug in -4, well, -4 plus 4 is a 0. You're never allowed to divide by 0. So that stays open. Okay, region 1, 2, and 3. So plug in -5. -5 minus 1 is a negative. Divided by, that's a fraction bar. -5 plus 4 is a negative. Negative divided by negative is positive. Is it positive less than or equal to 0? No, that's false. Don't shade in region 1. Region 2, 0. 0 minus 1, negative. 0 plus 4 is positive. Negative divided by positive is negative. Is a negative less than or equal to 0? Yes, that's true. Shade in region 2. And region 3, 2. 2 minus 1, positive. 2 plus 4, positive. Positive divided by positive, positive. Positive less than or equal to 0, that's false. So this is my region. Okay, in the back of the book, this would be a parenthesis. This would be a bracket. Okay, 27, you need to set up a little bit first. The original was 4 over x minus 6 plus 1. The common denominator is x minus 6, so I multiply by x minus 6 over x minus 6. So that gives me 4 plus x minus 6 over x minus 2. Comes out to be x minus 2 over x minus 6, greater than 0. Okay, then the rest of the problem is just like the other one. Okay, so my boundary numbers are 2 and 6. 2 and 6. They're both open circles. Okay, if I plug in 2, I would get 0 is greater than 0. That's false. If I plug in 6, that's already a mathematical no-no. You can never divide by 0. Okay, so open circle, open circle. In the back of the book, they'll have parentheses here. Okay, region 1, 0. Region 2, 4. Region 3, 7. Okay, 0 minus 2, negative. 0 minus 6, negative. Negative divided by negative, positive. Positive greater than 0, true. Shade that in. Okay, 4. 4 minus 2, positive. 4 minus 6, negative. Positive divided by negative, negative. Negative greater than 0, no, false. Don't shade in region 2. And 7. 7 minus 2, positive. 7 minus 6, positive. Positive divided by positive, positive. Is a positive greater than 0? True. So shade in that region. 29, just a little bit longer. X minus 2, x plus 3, x minus 4. So my boundary numbers are going to be 2, -3, and 4. Less than means they're all open. If I have the line underneath it, I might have some open, but as it is, they're all open. So regions 1, 2, 3, and 4. So region 1, -4. Region 2, 0. Region 3, 3. Region 4, 5. Okay, plug in -4. -4 minus 2, negative. -4 plus 3, negative. -4 minus 4, negative. Negative divided by negative times positive. 3 negatives makes a negative. Is a negative less than 0? That's true. Shade this in. In the back of the book, we'll have parentheses here. Parenthesis, parenthesis, parenthesis. Okay, 0, 0 minus 2, negative. 0 plus 3, positive. 0 minus 4, negative. 2 negatives makes a positive. Positive less than 0. No, that's false. Don't shade in region 2. Region 3, 3. 3 minus 2, positive. 3 plus 3, positive. 3 minus 4, negative. So the whole thing is negative, less than 0, true. And then 5. 5 minus 2, 5 plus 3, 5 minus 4, they're all positive. So the whole thing is positive, positive less than 0, false. So there's my solution. Okay, then a couple more, a little bit harder. Problem 31, it starts off with 2 over x minus 4 minus 1 over x minus 3. So get a common denominator, multiply this side by x minus 3 over x minus 3. This one by x minus 4 over x minus 4. So my common denominator is x minus 3, x minus 4. This comes out to be 2x minus 6 minus x plus 4, which comes out to be x minus 2. Okay, so now it looks like all the others. X minus 2 over x minus 3, x minus 4. Greater than 0. So 2, 3, and 4. Okay. Greater than 0 means open circle. The back of the book has parentheses. Okay, so pick something in region 1, 2, 3, and 4. Region 1, I picked 0. Region 2, 2.5. Region 3, 3.5. And region 4, 5. Okay, plug in 0 here, here, and here. It comes out to be negative, negative, negative. 3 negatives is a negative. Negative greater than 0, false. 2.5 minus 2, positive. 2.5 minus 3, negative. 2.5 minus 4, negative. Positive divided by negative times negative, positive. Positive greater than 0, that's true. Shade in region 2. Region 3, 3.5. 3.5 minus 2, positive. 3.5 minus 3, positive. Whoops, positive. 3.5 minus 4, negative. So I have 1 negative, that makes the whole thing negative. Negative greater than 0, no, that's false. Don't shade in region 3. And region 4, 5. 5 minus 2, positive. 5 minus 3, positive. 5 minus 4, positive. The whole thing is positive. Positive greater than 0, true. Shade that in. Last one, 15. X squared minus 4x plus 4 is greater than or equal to 0. This factors in x minus 2, or x minus 2 squared greater than or equal to 0. Okay, so ordinarily I would say lay down the 0 of the function, which is 2. That's fine. Okay, and pick something over here like 0, something over here like 3. Okay, but if you stop and think about it, you cover this up. You're squaring something. So if you're squaring something, it's always going to be greater than or equal to 0. The whole real number line is shaded. Everything works. You cannot choose a bad number in this particular case. They're all going to work. All right, so this was section 7.6.